This video is on the quotient rule for exponents, which I have written right here. It says if we have a to the m over a to the n, that is equal to a to the m minus n. And then we have a little note that the base in the numerator and the denominator is the same, so they both have the base a. Otherwise, we wouldn't be able to simplify this fraction any further. So let's look at an example. Say we have 4x to the 6th over 2x to the 10th. I'm going to write this as a product of two fractions. That way we can see each part a little bit clearer. So we can simplify the first fraction. That's just going to be 2. Then we have x to the 6th over x to the 10th. So that looks like a candidate for our quotient rule. We have our 6 is going to be our m, and this 10 is going to be our n. So we write our base, and then m minus n is 6 minus 10. So now we can rewrite this. 6 minus 10 is negative 4. Now we'd like to put this in positive exponents. So we're going to need to write 1 over x to the 4th. So now we have a positive exponent. Then we can write the 2 in the numerator, since 2 times 1 is just 2. And we are left with that as our final answer. Now let's take a look at a different example. Say we have c to the 6th and d squared, and that is going to be over c to the 5th times d. So we are going to write this as c. Our m for c is going to be 6, and our n is 5. Right, so this is our m, and this here is our n. And then for d, we have a 2 in the numerator, and the denominator we just have a d, so that's like d to the power of 1. So 2 minus 1. So then we have c, 6 minus 5 is 1, d, 2 minus 1 is 1. Then we can just write this as CD. So there's that. Now let's take a look at a more complicated example. So say we have 30 over 15. Then we have y to the 5th, z to the 10th, over y to the 7th, z to the 7th. So now we have three parts. We have our integers, we have exponents with the base y, and we have exponents with the base z. So we'll look at the 30 over 15 first. 30 over 15 can be simplified to 2 over 1. We'll just write it as 2. Then we have our base y. So for our base y in the numerator, we have our m as 5, and our n is 7. So we'll write 5 minus 7. Then we have a base z. So our numerator, we have 10 as our m, and then in the denominator we have a 7 as our z. So now we can do the subtraction. 5 minus 7 is a negative 2, and 10 minus 7 is a 3. Now we can just write this with positive exponents. So the y we're going to write as 1 over y squared. Then we have z cubed. So now we can write this with everything that's in the numerator. We have a 2 times a 1 times a z cubed, and then the denominator we have a y squared. So see where I got that from? There's a 2 here, a 1, and a z cubed. That's where that numerator comes from. So then this just becomes 2z cubed over y squared. And that's the answer for that. Now we'll take a look at one more example. So here we have 2t plus s, all raised to the 4th power, then 2t plus s raised to the 3rd power. Now we can notice here that our base is actually 2t plus s. So it doesn't matter that our base here is not just a single letter. Okay, so instead of a, where we have up here, now we have a 2t plus s. So that doesn't actually change our formula at all. So we're still going to have our m to be 4, and now our n is going to be 3. So now we can write this as 2t plus s, and then we have our m is 4 minus our n is 3. Well, 4 minus 3 is just 1, so we're left with a 2t plus s. And that is our answer for that example.